Space is usually described as a void of infinite silence, but for NASA, the silence is loudest in late January. On the calendar of human exploration, there is a 1-week stretch that bleeds. It is a statistical anomaly that feels like a curse, though any engineer will tell you that curses are just the visible scars of human error. Between January 27 and February 1, the cost of the stars is paid in full. In this 7-day window, 3 different crews, across 3 different decades, met the exact same enemy. It wasn't the unknown, and it wasn't the vacuum of space. It was a deadline. It was the crushing weight of a schedule. January 27, 1967, 3 men are incinerated on a launch pad in Florida. January 28, 1986, 7 lives vanish into a white cloud over the Atlantic. February 1, 2003, 7 more are scattered as debris across the Texas sky. This isn't a story about the glory of flight. This is a forensic look at industrial horror. It's about the go fever, that infectious, corporate sickness where the need to stay on track overrides the need to stay alive. It is the story of the engineer versus the manager. Physics is a cold, uncompromising judge. It doesn't care about budgets, State of the Union addresses, or the Cold War. It only cares about the math. And when the math says no, but the manager says yes, people die. Gus Grissom didn't trust it. The Apollo 1 command module was a mess of wires, plumbing, and compromises. It was a prototype being pushed to its absolute limit to beat the Soviets to the moon. Grissom, a veteran of Mercury and Gemini, was so disgusted with the craft that he plucked a lemon from a tree in his backyard and hung it on the flight simulator. He called the ship a bucket of bolts. On January 27, 1967, Grissom, Ed White, and Roger Chaffee climbed into the cockpit for a plugs-out test. It was supposed to be a routine simulation. But the moment they sat down, the omens started. A strange smell drifted through the cabin, the sour milk scent of a glycol leak. How are we going to get to the moon if we can't talk between 2 or 3 buildings? Grissom's voice crackled over the comms, dripping with frustration. The radio was failing. The wiring was a rat's nest of exposed copper. And, most lethally, the cabin was pressurized with 100% pure oxygen. In that environment, a single spark doesn't just start a fire, it creates a bomb. The engineers knew the risks. They had warned that the cabin was a tinderbox. They had warned that the door, a complex, 2-part hatch, was designed to open inward. It was a design flaw born of pressure. If the air pressure inside rose even slightly higher than the air outside, the door would be physically impossible to pull open. It would be sealed shut by the very atmosphere that was supposed to keep them alive. At 6:31 p.m., a wire frayed. A spark jumped. Fire. We've got a fire in the cockpit. Because of the pure oxygen, the interior of Apollo 1 went from a workspace to a furnace in seconds. The pressure spiked instantly, pinning the inward opening hatch shut with over 2 tons of force. Ed White, the strongest man on the crew, reached for the handle. He fought the door as the temperature climbed to 1,000 degrees. He never had a chance. The managers wanted the ship built fast, the engineers wanted it built safe. The villain of the Challenger disaster wasn't a loose bolt or a faulty computer. It was the weather, and the arrogance to ignore it. On the night of January 27, 1986, the temperature in Florida plummeted. Icicles, some a foot long, draped off the launch tower like stalactites in a cave. The engineers at Morton Thiokol, the company that built the solid rocket boosters, watched the thermometer with dread. They knew something the public didn't: the rubber O-rings, the massive seals meant to hold back burning rocket fuel, had never been tested in freezing cold. In extreme cold, rubber gets hard. It doesn't stretch. It doesn't seal. Roger Boisjoli, the lead engineer on the boosters, knew that launching in these conditions was a death sentence. He frantically pulled data, charts, and photos of previous damage to prove his point. He got on a teleconference with NASA management, his voice shaking with urgency. He told them, flat out, that launching below 53 degrees was unsafe. The forecast for the next morning was 18 degrees. But NASA had go fever. They had a schedule to keep. There was a rumor that President Reagan wanted to mention the launch in his State of the Union address that very night. They needed the shuttle in the air. When Boisjoli refused to back down, a NASA manager on the line asked the most infamous question in the history of engineering ethics: "My God, Thiokol, when do you want me to launch?" "Next April." The pressure shifted. The Thiokol managers, afraid of losing their contract with NASA, turned off the mute button. They looked at their engineers, who were screaming, "No," and ignored them. One manager turned to another and said the sentence that sealed the crew's fate: "Take off your engineering hat and put on your management hat." They signed the paper. They gave the recommendation to launch. Roger Boisjoli went home that night and told his wife, "I fought like hell to stop that launch. I'm so sorry." He knew he was about to watch 7 people die. The morning of January 28 was brittle and bright. The crew walked out to the shuttle, smiling and waving, unaware that the debate to save their lives had already been lost in a conference room the night before. At T-0, the engines ignited. A puff of black smoke appeared near the right solid rocket booster. The O-ring had failed instantly, just as Boisjoli predicted. But by a stroke of blind luck, a slag of aluminum oxide plugged the hole. It held the seal. For 70 seconds, they were safe. Then, they hit the wind shear. The shuttle was buffeted by the strongest winds ever recorded for a launch. The vibration shattered that temporary plug. A tongue of white-hot fire, hotter than the surface of the sun, escaped the booster and acted like a blowtorch, slicing right into the main fuel tank. At 73 seconds, Mission Control uttered the command, "Challenger, go at throttle up." Commander Scobie replied, "Roger, go at throttle up." Those were the last words heard from the Challenger. Milliseconds later, the external tank collapsed, and the aerodynamic forces tore the orbiter apart. The world watched a white cloud bloom in the sky. To the spectators, and to the families watching from the stands, it looked like an instant explosion. A quick end. But the horror of Challenger is that it wasn't quick. The shuttle didn't explode, it broke apart. The crew cabin, reinforced and pressurized, was ejected intact. It was flung free of the fireball, tumbling on a ballistic arc into the stratosphere. NASA investigators later found that at least 3 of the personal egress air packs, emergency oxygen masks, had been activated. Pilot Mike Smith's switch had been moved. Someone had turned it on for him. This means they were alive. They were conscious. They were falling. On the morning of January 16, 2003, the Space Shuttle Columbia roared off Pad 39A. It was a picture-perfect ascent into a cloudless Florida sky, but at 81.7 seconds after liftoff, the laws of physics silently condemned the crew. A piece of insulating foam, roughly the size of a briefcase, broke away from the external fuel tank's left bipod ramp. It tumbled through the violent slipstream, accelerating relative to the orbiter, until it slammed into the leading edge of the left wing. At highway speeds, foam is soft and harmless. But at the hypersonic velocity of the launch, mass multiplied by acceleration equals catastrophe. That lightweight foam struck the wing with the kinetic energy of a 50-pound concrete block dropped from a skyscraper. It smashed directly into reinforced carbon-carbon, RCC, panel number 8. These panels were the shuttle's armor, designed to withstand the hellish 3,000-degree heat of re-entry. The impact punched a gaping hole, likely 10 inches wide, directly into the thermal protection system. The crew felt absolutely nothing. Inside the cockpit, the vibration of the solid rocket boosters masked the impact entirely. Down in Houston, engineers reviewing the grainy launch footage the next day saw a white blur strike the wing and shatter into dust. But the management culture had grown complacent. Foam had shed on previous missions. It had caused dings and scratches before. They called it maintenance capability, not a flight safety issue. This was the normalization of deviance, the belief that because you got away with a risk yesterday, you will get away with it today. Columbia made it to orbit, but it was effectively a ghost ship. It was flying with a mortal wound, bleeding its future into the void, while the crew unbuckled to begin their science experiments, blissfully unaware that their shield was shattered. While the astronauts worked in space, a desperate, quiet war raged in the cubicles of the Johnson Space Center. Rodney Rocha, the chief structural engineer for the Thermal Protection System, watched the launch replays with a growing knot of dread in his stomach. He knew the physics of the impact were different this time. He knew that if the RCC panel was breached, the superheated plasma of re-entry would pour into the wing structure like water into a sinking ship, melting the aluminum struts in seconds. Rocha and the debris assessment team frantically begged for information. They pleaded with mission management to submit a formal request to the Department of Defense to turn their high-resolution spy satellites toward the shuttle. The satellites were already in orbit, they just needed to take a picture of the left wing to verify the damage. It was a zero-cost safety check. But the manager struck with lethal bureaucratic force. Linda Ham, the mission management team chair, blocked the request. The rationale was chillingly fatalistic. Even if there is damage, what can we do about it? The request was cancelled. In the halls of Mission Control, engineers who pushed for the photos were mocked for being Chicken Littles. Rocha sat at his computer and drafted a furious email detailing exactly how the ship would die, a burn-through on the left wing leading to loss of control. But, crushed by the hierarchy that ignored him, he never pressed send. Instead of a warning, Mission Control sent an email to Commander Rick Husband, assuring him the debris strike was inconsequential. The crew was told they were safe, betrayed by a management team that preferred ignorance to the terrible truth. For 16 days, the Columbia orbited the Earth in a state of ignorant bliss. While the crew admired the view of the Mediterranean and conducted biology experiments, a ghost ship was sitting on the launch pad in Florida that could have saved them. Space Shuttle Atlantis was being prepped for the next mission. NASA investigators later confirmed that if management had admitted the emergency immediately on day 2, they could have rushed Atlantis for a rescue mission. It would have been risky, breathless, and unprecedented lifeboat scenario where the Columbia crew would spacewalk from their dying ship to the rescue vessel. But you cannot rescue a crew if you refuse to admit they are in danger. The managers in Houston were not discussing rescue, they were discussing public relations. They were terrified of a delay. Instead of a rescue plan, they sent an email to the printer on board Columbia. It was a good news note from Flight Director Steve Stick. He casually mentioned the debris strike but told Commander Rick Husband, "We have seen this phenomenon on several other flights, and there is absolutely no concern for entry." It was a lie born of wishful thinking. The crew read that email and felt relieved. They joked about the foam. They trusted the ground. They had no idea that beneath their feet, the thermal protection system had a hole the size of a dinner plate. They were dead men flying, kept sedated by reassurances, wasting their final days performing science experiments while the clock on the wall ticked down to a physics equation that could not be solved. On the morning of February 1st, the Columbia fired its maneuvering thrusters to slow down. This is the orbit burn. It is a commitment. Once you slow down, gravity takes hold, and there is no turning back. You must fall. The shuttle flipped over, flying tail first to brake, then flipped back around to face the fire. They hit the entry interface over the Pacific Ocean at 400,000 feet, traveling at Mach 25, 25 times the speed of sound. At this speed, air cannot move out of the way fast enough. It gets crushed. The compression heats the air to plasma, a state of matter so hot it glows purple and white, stripping electrons from atoms. This creates a radio blackout. For several minutes, the shuttle is wrapped in a sheath of ionized fire, cut off from the world. This was normal. What wasn't normal was the yaw. Usually, a shuttle glides like a brick. But Columbia started to fight. The autopilot began firing jets on the right side frantically. Why? Because the left wing was developing drag. The plasma wasn't just flowing over the wing, it was flowing into it. The hole was inhaling the fire. Inside the wing structure, aluminum spars were melting like butter in a skillet. The wiring bundles, the nervous system of the ship, were being incinerated. The ship wasn't just falling, it was being eaten alive from the inside out, all while the crew watched the pink glow out the window, thinking it was just the beautiful violence of coming home. In the windowless, climate-controlled bunker of Mission Control in Houston, the catastrophe did not arrive with an explosion or a scream. It arrived as a subtle statistical anomaly on a green monochrome screen. At 8:54 a.m., Jeff Kling, the maintenance, mechanical, arm, and crew systems officer, sat up straighter in his chair. He was looking at the telemetry stream from the shuttle's left wing. "Flight, Max," Kling said, his voice level and professional. "I see no tire pressure on the left inboard and outboard tires." Flight Director Leroy Kane, a man known for his steely composure, furrowed his brow. "Copy," he replied. "Is it instrumentation?" They were troubleshooting a sensor error. They thought it was a glitch. It was the manager's mindset, in real time, assuming the machine is wrong, not that the machine is dying. But the data was trying to scream the truth. The sensors hadn't failed, they had ceased to exist. The superheated plasma had melted through the hydraulic lines and burned the wiring bundles into ash. The off-scale low reading wasn't a zero, it was the electronic equivalent of a flatline. The ship was bleeding to death, losing its nervous system one wire at a time, while the ground control debated instrumentation errors. For 4 minutes, they stared at the screens, analyzing the ghosts of sensors that had already been incinerated. At 200,000 feet above Texas, the physics of the situation became violent and absolute. The left wing, now a hollow shell filled with plasma hotter than the surface of the sun, finally surrendered. The aluminum struts turned to liquid. The wing folded upward and snapped off. The Columbia ceased to be a flying machine and became a tumbling projectile moving at 18 times the speed of sound. The aerodynamic forces were so immense that the orbiter was ripped apart in milliseconds. This is the moment of the unzipping. The crew module, the reinforced compartment holding the 7 astronauts, was severed from the fuselage. On the ground in Dallas, early risers looked up to see a strange, terrible beauty. The single bright streak of the shuttle suddenly fractured. It looked like a firework failing in slow motion. One trail became 2, then 4, then hundreds. To the observers, it was silent. The sound of the sonic boom, the shockwave of the disintegration, wouldn't reach the ground for another 2 minutes. Up in the stratosphere, the crew was subjected to spin forces that exceeded human tolerance instantly. The pressure suits they wore were not designed for a vacuum at Mach 18. The manager had deemed full survival suits too heavy and expensive. The physics of the fall took over, and the week of death claimed its final 7 victims in a rain of metal over the American South. In Mission Control, hope is a procedure, but silence is a verdict. After the tracking map froze and the radio checks went unanswered, the room fell into a stillness that was heavier than gravity. Flight Director Leroy Kane, tears welling in his eyes but his voice rock steady, uttered the command that every flight controller trains for but prays never to hear: GC, flight. Lock the doors. This order marks the instant transition from a space mission to a crime scene investigation. It means no one leaves, no data is deleted, and every phone call is logged. The screens, which moments ago showed altitude and velocity, now displayed static data points of a ship that no longer existed. In the viewing gallery, the families of the crew, who had been cheering just minutes before, were quietly escorted out by astronauts in civilian clothes. They were led to a secluded room to be told that the wait was over, but the reunion would never come. The coffee cups were still warm on the consoles, but the era of the space shuttle was effectively over. The room was sealed, preserving the exact moment that arrogance finally caught up with engineering. The Columbia did not land in Florida, it rained down upon East Texas and Louisiana. A debris field stretching 200 miles long and 10 miles wide turned the pine forests into a graveyard of high technology. What followed was the largest search and recovery operation in history, a grim procession known as the Harvest. 25,000 people, firefighters, volunteers, forestry workers, walked shoulder to shoulder through the mud, scanning the ground for pieces of the ship and its crew. They found twisted titanium spars sticking out of the ground like spears. They found singed mission patches. They found the black box data recorder, miraculously intact in a bog. But the horror was in the intimacy of the wreckage. The searchers weren't just finding metal, they were finding the consequences of the go fever. A helmet here, a glove there. Every piece of debris was tagged, bagged, and shipped to a hangar at the Kennedy Space Center, where a heartbreaking jigsaw puzzle was assembled. The grid on the hangar floor recreated the shape of the shuttle, a two-dimensional ghost reconstructed from 84,000 fragments, solely to prove what Rodney Rocha had known 2 weeks earlier: the hole was in the left wing. Following the Challenger disaster, Washington did what it always does: it formed a committee. The Rogers Commission was filled with politicians and astronauts who wanted to protect NASA's reputation. But they made a mistake. They invited Richard Feynman, a theoretical physicist who had no interest in protecting anyone's reputation. He only cared about the truth. For weeks, NASA managers sat before the commission and used sanitizing language. They spoke of safety factors, thermal distress, and allowable erosion. They tried to drown the death of 7 people in a sea of acronyms. They claimed they had no data proving the cold was a factor. Feynman sat in the back, looking disheveled, playing with a C-clamp and a piece of rubber O-ring material he had swiped from the lab. On live television, Feynman cut through the bureaucratic fog with a glass of ice water. He took the rubber O-ring, clamped it tight to simulate the pressure of the rocket boosters, and dropped it into the ice water. He let it sit. The room went silent. When he pulled it out and removed the clamp, the rubber didn't spring back. It stayed compressed. It was dead. In 10 seconds of simple physics, he proved that the seals failed in the cold. He humiliated the managers who had signed the launch order. His final report contained the most damning sentence in the history of government investigation, a maxim that should be engraved above every door at NASA: for a successful technology, reality must take precedence over public relations, for nature cannot be fooled. 17 years later, during the Columbia investigation, the investigators found that the enemy had evolved. It wasn't just a lack of data, it was the way data was presented. The weapon that killed the Columbia crew wasn't just foam, it was a PowerPoint presentation. While the shuttle was still in orbit, Boeing engineers prepared a briefing for NASA management to assess the damage. The critical information, the fact that the foam strike could be catastrophic, was buried on slide 28. It was a masterpiece of bad communication. The headline of the slide was, "Review of Test Data Indicates Conservatism," a phrase that led managers to believe the estimates were safe. The actual warning, that the foam could cause severe thermal damage to the wing, was hidden at the very bottom of the page, in the smallest font size, preceded by 4 levels of bullet points. It was text-dense, confusing, and dry. When the managers saw the slide, their eyes glazed over. They saw the word conservative and assumed safety. They didn't read the fine print. Edward Tufte, a world-renowned expert in information design, later analyzed that specific slide and concluded that the chaotic formatting allowed the managers to confirm what they wanted to hear, that everything was fine. The engineers had technically delivered the warning, but they had whispered it in a room full of noise. The "go fever" didn't just ignore the science, it hid the science behind bad graphic design, and 7 astronauts paid for that slide with their lives. The most terrifying finding of the Columbia investigation was not technical, it was sociological. When the investigators placed the 1986 Rogers Commission report next to the 2003 CAIB report, they found they were reading the same document. The chapters had changed, but the plot was identical. In 1986, NASA convinced itself that because O-rings had eroded before and the shuttle didn't explode, it was safe to fly. In 2003, they convinced themselves that because foam had fallen before and the shuttle didn't explode, it was safe to fly. Sociologist Diane Vaughan coined a term for this, the normalization of deviance. It is the slow, creeping cancer of high-stakes industry. It occurs when people grow accustomed to unsafe practices simply because nothing bad has happened yet. It is the logic of a drunk driver who believes they are skilled at driving drunk because they haven't crashed, until the night they do. NASA hadn't fixed the culture that killed the Challenger crew, they had merely suppressed it. For 17 years, the ghost of the "go fever" hid in the walls of the Johnson Space Center, waiting for a new generation of managers to lower their guard. The shuttle program was designed to be a reusable truck, but management treated it like an airliner, forgetting that every single launch was a controlled explosion requiring perfection. The echo of 1986 was deafening, but no one in 2003 was listening. There is a fate worse than dying in the disaster, being the engineer who predicted it. Roger Boisceli, the man who begged them not to launch Challenger, didn't die on January 28, 1986, but his life effectively ended. He was shunned by his colleagues at Thiokol. He was treated as a traitor for testifying about the management's incompetence. He suffered from severe depression, headaches, and the crushing weight of survivor's guilt. He spent the rest of his life traveling to engineering schools, telling students, "I hope you never have to pay the price I paid for being right." Rodney Rocha, the Columbia engineer, carried a similar cross. He had to live with the memory of the enter key he never pressed. He had to walk past the empty offices of the crew members he had tried to save. These men are the collateral damage of the manager's arrogance. They are the Cassandras of the modern age, cursed to see the future and powerless to stop it. Their stories transform these disasters from industrial accidents into Greek tragedies. The hardware can be replaced. The launch pads can be scrubbed clean of scorch marks. But the psychological scars on the people who knew the truth, who saw the math and screamed into the void, never heal. They are the living ghosts of NASA's week of death, wandering the halls of history, reminding us that the silence of a manager is often deadlier than the roar of a rocket. Every year, towards the end of January, a heavy silence descends upon the Kennedy Space Center. The tourists are still there, snapping photos of the rocket garden, but for the workforce, the atmosphere changes. They call it the Day of Remembrance, but it feels less like a ceremony and more like a penance. It is the only day on the calendar where the relentless forward motion of the agency halts to look backward at the wreckage it left behind. At Arlington National Cemetery, and at the Space Mirror Memorial in Florida, a ritual plays out that is heartbreaking in its repetition. A bell is rung. A name is read. A wreath is laid. But the true weight of the day is found in the faces of the crowd. You see the widows of Apollo, now in their 80s, standing alongside the children of Challenger and Columbia, children who are now older than their parents were when they died. They are the living monuments to the "go fever." For the current generation of astronauts, this week is a reminder of the contract they signed. They walk past the memorials and see the faces of Gus Grissom, Judy Resnick, and Kalpana Chawla carved into black granite. The granite is polished to a mirror finish, so when you look at the names of the dead, you see your own reflection staring back. It is a chilling architectural choice. It forces every engineer and every manager to look the dead in the eye and ask, "Am I cutting a corner today? Am I ignoring a warning? Will my name be next?" The vigilance of late January is the only thing keeping the demons of complacency at bay, but human memory is short, and the granite is cold. The space shuttle is retired. It sits in museums, a relic of a beautiful but lethal era. But the beast that killed those 17 people, the "go fever," did not retire. It simply changed uniforms. We are now in the age of Artemis. We are in the age of SpaceX, Blue Origin, and the commercialization of the cosmos. The slogan of Silicon Valley is, "Move fast and break things." That philosophy works fine for software apps and cell phones. But when you apply, "move fast and break things," to human spaceflight, the things you break are human bodies. The pressure today is higher than it was in 1986 or 2003. The enemy isn't the Soviet Union, it is the bottom line. It is the shareholder report. It is the vanity of billionaires who want to conquer Mars before they die. The engineers are still there, spotting the cracks, flagging the risks, and worrying about the O-rings of the future. But the managers have become CEOs. The deadlines are now tied to stock prices and quarterly earnings. As NASA prepares to send humans back to the moon and eventually to Mars, the whispers in the hallways are starting again. We need to launch by 2026. We need to beat China. We need to prove the investors right. The ghosts of Apollo 1, Challenger, and Columbia are screaming from the past, warning us that physics does not care about a pitch deck. The laws of thermodynamics cannot be disrupted by a startup. If we allow the schedule to become the master again, the calendar of death is waiting to add a new week, and a new list of names, to its tragic ledger. The universe operates on a set of immutable laws that cannot be bribed, charmed, or bullied. In the boardroom, you can spin a narrative. You can hide a budget deficit with clever accounting. You can suppress a dissent with a threat of termination. But at Mach 25, or in a 100% oxygen environment, or at -20 degrees, the laws of thermodynamics and aerodynamics are absolute dictators. They do not care about the State of the Union address. They do not care about the pressure to launch. They do not care that you are a hero, a teacher, or a father. They only care about the equation. The tragedy of NASA's week of death is that in every single instance, the equation was known. The engineers had solved it. They knew that $P equals F/A$, pressure equals force over area, meant the Apollo hatch would never open. They knew that the glass transition temperature of rubber meant the Challenger O-rings would shatter like crystal. They knew that $E equals 1/2 mv²2, kinetic energy, meant a piece of foam would hit like a cannonball. The math was on the desk. The managers simply chose to look at the calendar instead. This is the ultimate horror of the story. It wasn't a mystery. It wasn't an act of God. It was a calculated gamble where the collateral was human life. When we look back at the scorched metal of Apollo 1, the twisted debris of Challenger, and the scattered remains of Columbia, we are not looking at accidents. We are looking at the receipts of a transaction. We are looking at what happens when human arrogance tries to negotiate with the fundamental constants of the universe. The universe always wins the negotiation. The cost of admission to the stars is high, but the cost of ignoring the math is total. The wreckage is the proof that while you can ignore the engineer, you cannot ignore the engine. So we return to the calendar. Late January. The sky is usually gray, the wind is cold, and the flags at the space centers fly at half-staff. We light the candles and we read the 17 names. But the most haunting part of this story isn't the fire, the ice, or the foam. It is the silence that follows. It is the empty chair at the breakfast table that has stayed empty for decades. It is the graduation ceremonies, the weddings, and the grandchildren that never happened because a meeting ran late and a slide was ignored. As we stand on the precipice of a new era, looking toward Mars with hungry eyes, we must carry the ghosts of this week with us. We must strap them into the seats beside us. The "go fever" is waiting in the wings, ready to infect the next generation of billionaires and bureaucrats. It will whisper that safety is too expensive, that testing is too slow, that we need to launch now. When that happens, we must remember the sound of Gus Grissom's frustration. We must remember the look in Roger Boisjoli's eyes when he realized no one was listening. We must remember the silence over Texas. We honor the dead not by building statues, but by listening to the engineers who say no. We honor them by remembering that the laws of physics are written in stone, not in pencil, and they do not bend for anyone. The week of death is over, but the lesson is eternal. Gravity doesn't negotiate, and physics doesn't care about your schedule. Subscribe the Crimson Files for more.